All right, so in the last few videos, we've seen that we can manually tell Git to store characters, single strings like hello and goodbye, and it will store them in the objects directory. It creates a file using the hash. So here I'm just showing, the hash file. I'm not showing the subdirectory it's nested inside of. Technically, the hash, the first two characters make the directory name, right? And then the other 38 make up the file name. But anyway, it stores the contents, in this case, hello, in the file, and it names it with this key, with the hash. And then I can put something else in there, like goodbye and chicken. Or I could have different versions of files, which is more realistic. I can have 100 lines in a file versus 1,000 lines in the same file, or store 10 different files. Git is going to create objects for each of them. And then, at any point, we can manually say, hey, here's the key for something. Please go give me the corresponding data. And we saw Git was able to do that. So at this point, everything that we have stored, all of the stuff in this objects directory, they are examples of one type of a Git object called blobs. Binary large objects, blob. So this is one type of an object Git can store. Remember, there are 4. Commits are one. Blobs are another, something called trees we'll see next. And then annotated tags, we don't care about those so much. But really, blobs, commits, and trees are the most important. So a blob is used to store the content of a file. It is just the content of a file, just the insides. It doesn't include even the file name. It's just the content. So what we've done so far is created a couple of blobs. This is a blob, this is a blob, this is a blob, this is a blob. They are just content that we've stored. Now what's interesting, as I said, is that the file name is not included. So you can visualize a blob like this. This is the content in a file, some JavaScript file. Git, of course, keeps track of a file name, and that's where trees come in. But Git stores the contents of a file separate from the name. And then each blob gets its own hash. We've already seen that. These are blobs. We created a blob. It got this hash. This is a blob. It has this hash, 39E275. This is a blob, CE0136. Blobs are a building block of the way that we use Git, where we have different files and different contents and different versions and commits. They play a very important role, as you'll see. But on their own, a blob is just a Git object that stores the contents of a file. Doesn't even include the file name, but it does get its own hash. So it's not a commit hash, it's a blob hash. They might look like a commit hash, but that's just because they're all 40-character hexadecimals, right? It's impossible to tell them apart. And they're the output of the same SHA-1 function. Anyway, that's an intro to blobs. In the next video, we get to talk about trees.